a lunch and learn on Onshape. I might start with a few quick little norms that we're going to follow for this. It's going to be pretty interactive because we want you to be learning some of the skills, tips, and tricks of Onshape so you can bring it back to your classroom and be able to share it with your students. A few things just to keep it interactive. Feel free to use chat to interact and for any immediate questions. We have two incredible other team members who are also on this call, Jordan and Jillian, and they're going to be monitoring the chat. You can put anything in there and they'll make sure that you're able to get any questions answered as well. We make it a Zoom meeting so anyone can be able to ask questions live as well and be able to speak. So then you can unmute yourself whenever and then be able to ask questions in that way as well. Or if I ask any questions for you to be interactive, feel free to take yourself off mute to answer the question. And finally, the deck will be shared after this. So if you want to just sit back, pay attention, we will be sharing the recording and the deck afterwards. So what we're looking at today, we're going to do a quick introduction to Project Invent and who we are and why we host these, and then jump straight into learning about CAD in general or computer aided design, and then Onshape, and learn some basic skills before doing a mini project that is a good way to introduce Onshape or any computer aided design software to your kids. Then we'll close with questions. All right, so a quick introduction to Project Invent. We are a national nonprofit that works with high schools across the country to get students inventing for social good. So we believe in empowering every student as an innovative problem solver. We have students choose problems that they care about in their community and then work directly with people affected by those problems to be able to design innovative solutions. So that could be people like Jimmy, who's blind, or Jose, who's a classmate of some of our students in Washington, who is a teenager with cerebral palsy. Or they're working with Abigail, a senior citizen in their community, to learn about how she navigates with a wheelchair and continues to practice art despite her arthritis. And they figure out, what can I build, what can I design, and what can I invent to be able to help people tangibly around me. The way we run that is through 3 pillars: design thinking, engineering, and entrepreneurship. Today, with our lunch and learns, we're focusing a little more on the engineering side, but we offer this whole suite of tools for how we encourage students to go from coming up with a problem that they're passionate about to coming up with an idea, making that idea reality, and then making it in the real world. Some of those have varied from everything from adaptive video game controllers to concussion prevention. Students are really encouraged to tackle problems that they're passionate about and then learn engineering skills within that context. And that's something we really encourage as a way to introduce things like 3D design as well. So a few different things that are coming up that we're really excited about. This Saturday, so in just a few short days, we're having our first demo day. We're having 3 of those this year, where our students who have been working on Project Invent throughout the year are going to be pitching their inventions to real investors from Silicon Valley, and they're going to be able to get funding. So that opportunity is something you should tune into. You can tune in for one pitch, you can tune in for the whole 3-hour event, and you just go to demoday.projectinvent.org that Jillian just dropped in the chat to be able to RSVP for that. And then there's lots of opportunities. I'm guessing that many of you guys are teachers if you're coming to this event, and we have a few different opportunities of how you can get involved in Project Invent beyond Lunch and Learns. One, we have the Pathfinder Summer Institute, which is a great opportunity to spend your summer, a week of your summer with us, to learn that full design thinking, engineering, entrepreneurship process. And we also have a fellowship where that engages you in that year-long process that ends in the demo day that you'll see on Saturday, where you'll get a chance to be trained, join a cohort of other innovative teachers like you, run the program throughout the year, and then be able to have your students pitch at that final demo day. Many of these opportunities are free, especially if you're from a Title I or a public school teacher. Great, so we're just gonna jump right into our intro to CAD. So CAD is computer aided design, and this is something I'm really love and I'm passionate about. I was previously a mechanical engineer before starting Project Invent, and spent many, many hours in CAD softwares to be able to design and build different ideas and inventions. And I think it's really important to be able to have students have and be empowered by those same skills so they can make their own ideas and visions of reality. So there's a few different types of CAD. The one you might be familiar with is, if you guys grew up with MS Paint, you might be familiar with computer aided design in the 2D sense. You've been able to draw or paint or use the paint bucket or write text. That's all 2D design to be able to create graphics or art. What we're going to delve into today is 3D design, and that's really powerful because then you can create objects that then you can create in the real world. A lot of people use CAD as a way to model different ideas they have, but with the advent of 3D printers, that made it even more powerful. You can not only model and try to look at what it would look like on a screen, but you can physically print it and hold it in your hands after to really have a good idea of what you're trying to build. There's a few different CAD options, and I might go through some of them. So Onshape is what we're covering today. It's a web-based platform, and it's really great, especially for students who only have access to Chromebooks, and it has this really great feature that's really rare in CAD where you can real-time collaborate. So it's kind of like the Google Drive of 3D design right now. It's more advanced, but a little less used than another one I'll talk about, Fusion 360. Tinkercad is a more basic program, and it's also web-based. You just go to a website and then you can access it. And that one's a really good one for introducing kids to CAD because they give you shapes that you just stack on top of each other. You can think of it as like digital block building. And students can really just jump in and start using it instantly, whereas there's a little more of a learning curve for Fusion 360 and Onshape. And then I'll also mention Fusion 360 because that's the industry standard, and it's just good to know what people are using in CAD in the real world too. Onshape is slowly becoming pretty quickly becoming the more and more adopted one within the engineering industry, but Fusion 360 and another program called SolidWorks were very much the like dominant softwares that were being used. You download it to your desktop instead of logging into a web browser, and they also are more advanced. But by learning how to do Onshape and the like intermediate advanced skills we're going to learn today, you can carry those over to any of these softwares. So let's talk a little bit about how CAD works. So with CAD, you're going to be modeling shapes on a computer before you're building or manufacturing it. It's a good thing to be using to more efficiently prototype. A lot of engineers use it to perform calculations on whatever they're building, so it's very precise before they build it. And it really helps streamline the design process. Instead of sketching something and hoping someone understands what you're doing, you can be very, very precise about exactly how long or how wide you want something to be, and then share a file with someone instead. So the two, there's a few different modifications you do in CAD, but the ones that we're going to learn about are extrude and revolve. And the way you can think about designing in these more advanced CAD softwares in general is that you take a basic shape and then you do a modification on it. So when we look at the extrude one, you make a basic shape of a square and then you're pulling it up, and that's how you're making it 3D. That's an extrusion modification, and then it's suddenly 3D. For a revolve, they kind of show the little shape that they're using to create kind of this like washer type design. But they take this polygon, they make a basic 2D shape, and then they do the modification of it, of revolving it, and that's how they're making it 3D. So you can think of all CAD as what basic shape do I start with, and then what modification will make it 3D. So we're actually going to practice that really quick. So I'm going to start with a cylinder. There's a few correct answers to this one, so would love to hear what creative approaches you have for this. So if anyone wants to come off mute and tell me what is a base shape and what modification, either extrude or revolve, you would do to make a cylinder.
You could make a circle and then extrude it up.
Awesome, exactly. Can anyone think of another way you can do it?
You could create a rectangle and revolve it around one of its sides.
Exactly. So by taking this concept of base shape and modification, you can do a lot to create the same type of shape. Let's try another one. We're going to do a cone. How would you make this? What's the base shape? What's the modification? I know some of you guys know it.
You can make a right triangle and then revolve it around an axis.
Exactly. Yeah. And then you're able to make that cone through a revolve. Extrude would be much harder for this one. But technically you could like make a lot of stacks of circles on top of each other if you really wanted to make a cone through extrusion. And then finally, this is usually the challenge one I give students because it's not completely intuitive. What do you think the base shape and the modification are for a sphere? And the tricky part is the base shape part. So if you have an axis in the middle, that's what it's going to revolve around. What base shape needs to be there in order for it to revolve around and create a sphere?
You could do a circle 180 degrees, or you could do a semicircle 360.
Awesome. Yeah, that's perfect. I will say the program sometimes complains if you do the 180 circle because technically it's like not creating a full shape at some points. But the semicircle and the axis down the middle and turning it 360 will always work whichever program you use. So that's just to help you get in the mindset of what does it look like to do CAD. Another really key part, especially these days about CAD, is how 3D printing works. 3D printing, as opposed to anything else you've seen of like a saw or anything that you'd like see in a typical wood shop, like a bandsaw or a drill, those are all subtractive processes. You're removing material in order to create the thing that you want to create. 3D printing is really interesting and was really game-changing because it was one of the first additive processes. You're actually creating an object from nothing. You're taking material and you're extruding it or laying it down to create the material, rather than if you were trying to create the cityscape in a subtractive way or the typical way, you would take a solid block of wood and then you would carve away at it. You would subtract the parts you didn't want. For 3D printing, you're adding, you're creating every single piece that you want. And whenever you create something with CAD, you can always 3D print it afterwards, which is a really exciting piece for students. 3D printing lets you create fast, cheap models and test ideas throughout the way. So a good example is a shoe. Say you create a shoe in a CAD software, you 3D print it, and then you're able to like try it on, see if the sizing's right, see if the mold is correct. Another great example that I feel like kids really love is prosthetics. So I always show some 3D printed prosthetics, especially with animals. Those are always ones that really tug the heartstrings. So it gives a social good context to how you can use 3D printing. So we're going to learn a few things today. I'm going to have you start getting your Onshape website open because then we're going to jump into the CAD tutorial. And we're going to learn 3 of the most important features today. So sketch, dimension, and extrude. Sketch and dimension help you make your base shape. Extrude and revolve are going to be the modifications that we learn. And then as we saw, you can basically take mostly any shape and then use extrude and revolve in some way to be able to create that. And then a few shortcuts just to remember that we'll talk about as well. The escape key is one of your best friends. If something's not working in Onshape, it's likely you like entered the wrong feature. So you can click escape and it goes back for you to let you select and start over. We'll also learn rotate view and how to finish up your sketch. So the activity that always kids really love is making Lego people. We are going to make and it's really easy to print because they're so small. You don't need to use that much material. It doesn't take that much money in terms of material that you're using, and they get to create something custom. So they can either make it look like themselves or their favorite superhero, and it just gives a lot of customization. Today, we're going to do a base Lego person. So I drew a mini one over here of what that's going to start to look like and how you're going to continue to modify it of adding hair or adding faces or anything else to make it more personalized for your students. So before we move to Onshape, do we have any quick questions? Awesome. All right, well, I have Onshape open. Hopefully you made an account beforehand. If not, you can make one really quick, but this will just speed things up if you have already made one. So just go to onshape.com and then you do sign in. And then yours should let you sign in, and then you're going to be creating something new today. So you are going to hit that create button. You're going to create a document, and I'm going to call mine Lego person lunch and learn. And then anytime throughout this, you can unmute yourself and say slow down or type a question in the chat, and we're going to be able to help you out and help you get caught up. All right, so now we're in the main site of Onshape, and we want to start making our Lego person. So for me, I'm going to look at my reference again. They have a head, a like trapezoid body, 2 arms, and 2 legs. So I'm going to start with the head. It's kind of cylindrical. So the first thing I'm going to do is click the plane that I want to draw on top of, because I'm going to create a sketch. I'm going to click sketch, and then I'm going to create a circle because I'm creating a cylinder. I want my base shape to be a circle, and then I'm going to extrude it. So I click on circle. When I hover over this origin point, it turns yellow. That seems like a good place to build my circle. And then I click once on the yellow point, click once out, and then it creates a circle even when my cursor is not there. So if anyone has any questions about that part to start, slow us down. Any questions about how to create the circle, get Onshape open, click on the front plane, top plane? Great. Okay, so the next part before you extrude it is you are going to dimension it. The shortcut to dimension is you click the D. It also has the feature button is over here on my screen. It's one of the furthest right ones. So that one's dimension. And you're gonna click on once you hover and your circle turns orange, that's when you can click. And then it will tell you how large it is right now. So when I click again, it says right now it's 2 inches. That's probably pretty large for a Lego person. I might go like 1 inch instead as my diameter of my circle that I want to extrude. So I will type in 1 and then click enter, and then it shrunk. And now it's black instead of blue, which means that it's fully dimensioned. So now that I've sketched it, I can get ready to extrude it. The extrude button is close to your furthest left button. So dimension is almost your furthest right. Extrude is almost your furthest left. So it's this cube within a cube button. You're gonna click on that. And then it already has a preview of what my Lego head is gonna look like. I kind of like the 1 inch 1 by 1 inch, so it automatically did 1 inch. I'm pretty happy with that, so I'll click check. So that's the start of my Lego person head.
We have one question in the chat. How can I change my dimension units, inches versus meters?
Yeah, you can change your defaults through, I think it's document properties. Whoops, not this one. Workspace units. So if you click on the triple line in document menu right next to the Onshape logo on the left, there's an option called workspace units, and you can change your default to whatever you want. Inches, centimeters, foot, inches, meters, millimeter, or yard. No problem, Andrew. All right. Can I get a thumbs up if you have your head? Woo. Awesome. We got some heads going. So now we can create the body. For the body, I saw that there is a cylinder as a head and the body is kind of like a trapezoid. So I'm going to go back here and I can make it a trapezoid. I can make it a rectangle. I might just make it a rectangle for simplicity's sake. For my body, I think it will be easier if I draw on the front plane instead. Then I can draw a rectangle and then I can extrude it out in that way. So I can click on the front plane and now it's facing the face of it. Highlight my front plane orange and I'm going to sketch a rectangle. So it tells me when I'm in line with the origin by becoming orange. So I can just take that and then create a rectangle right under it. And then that rectangle I'm going to extrude. I need to dimension it again. So you can either hit little d or hit the feature button. Maybe if my head is 1 inch, maybe I want this to be 2 inches. Then I want this line on top I want it to be a little wider than the body. So maybe I'll make it 1.7 inches. And then it's not centered right now. So that's something that I can, restore. That's something I can try to change as well. So one way to do that is we can try to create a line in between the top corner and this corner. Another one here. Basically, we're trying to find the center point of our rectangle right now by creating lines. And then I can create a point in between them. So now I have a center point. And then I can take that point. I can take this point. And then let's try to align them. So now I can just drag it and then it should be able to align. The one trick you have to do when you create these lines in the middle of a rectangle is you need to make them construction lines, which is this middle feature right here, where it has a line with an arrow to a dotted line. So I'm going to change those into construction lines because I don't want them to be actual lines. I'm only using them for measurement purposes. So that was this feature to create those middle lines into construction lines.
How do you drag, like my rectangle won't just drag back and forth? Is there a certain way to do that?
Usually you want to drag something that's blue on it. So if there's like a line or a dot that's blue, usually it should be able to drag that part.
Thank you.
All right, so now I have my sketch and I want to be able to see when it extrudes. So I'm gonna look at this little like cube in the corner, and then I'm gonna turn what it's facing so I can see the 3D version of my Lego person again. So I click on this little corner and now I can see a view of the cylinder is 3D and I want to make this rectangle 3D now. So I'm going to click on the rectangle, extrude it again. And then this is when we're going to go into different types of extrusion. So the default is going to be a blind extrusion, which basically goes from one side onward. We're actually going to do a symmetric one. So then it's creating an extrusion, but with what we sketched as the middle of the shape. So then we don't have like an awkward rectangle that's offset from the head. We can line the head right up with the body. So I'm going to do a symmetric 1-inch extrusion. And click check. Now I have a little bit more of my Lego person. Any questions so far about making a body, about extruding a rectangle versus a circle, and like how you do different planes?
How do you align 2 points again?
I just dragged the point that I created in the middle to the other point. And then it locks in when it's in line with each other.
Oh. Mine's not.
Let me think if there might be another way. We can try that with, maybe I'll try to do that with I'm going to create one arm on one side of my Lego person, and then we'll try to see if there's another way that you can try. So in order to create the arm, I want to, so if this is the front of my Lego person, I need to go to the side of it and create an arm on one of its sides now. So I'm going to do a sketch again on here. I'm going to turn it towards me so it's easy for me to see. And then I'm going to create a rectangle again. So now I have a rectangle. I'm going to dimension it. Maybe I want my arm to be 0.5 length or width and 1.5 length. And then if we want to try to align it again, let's try that with this rectangle. So we're going to do our lines. We're going to create a point in the middle. I don't know if you did this part. Maybe that's the part that was having trouble. But if you put a point in the middle, then you should be able to, oops. Restore. We want to delete that part. You should be, so I'm able, do you see how I'm able to drag this around from the point I created?
Yeah.
When I drag it closer to the middle, it just snaps in to the middle because there's another point associated with it.
I had converted my lines into construction lines before adding the point, so maybe that could have been it.
Maybe. I don't think that should cause that issue. And you definitely have a point already in there in between the
Yes.
construction lines. So strange. I think it might be offset, and then I would just try to go through what process I just went through again on a clean sketch later. But hopefully maybe something like got mixed up in the beginning, and then by trying it over again with a clean sketch, you'll be able to get it working.
Yeah.
But hopefully the concept will be retained. Let me make these into construction lines again. And then I will be able to extrude this arm. I turn it a little so I can see how far it's extruding. That arm is too large, so I'm gonna change it to like 0.25 instead. So it's a bit of a skinnier arm. And then I have one arm. So then you can do that for the other side as well to get your other arm. And then for your legs, I'm gonna do that part because I feel like that part's a little bit trickier than the other arm. Does anyone have any questions so far? Or feeling good? Sweet. Then I'm gonna draw on the front side again. And this is when you kind of get creative and it looks more like MS Paint when you're not doing a solid shape. Essentially, I'm gonna do a sketch on the front plane and I'm just gonna draw lines that kind of look like a pair of legs because it's not a concrete shape. So let's see, I might draw this, stretch it over a bit. Then I probably want like more of a curve to the like bottom of the legs. So I do that. And this part you just like get a little creative with. You double click when you want to end a spline or the curvy part. Then I'll draw another line that I'll connect up here. Now I have the base of what probably will look like legs. Yeah.
Curve? Sorry, how do you make the line curve?
I used this option, which is called spline. Instead of clicking the line, you click on spline, and you can, wherever you click, it will curve to that new point.
Cool, thank you.
So if these are my pair of legs, I can now take them, extrude them. And then again, we don't want to do a blind one or it'll just offset like that. So we want to do symmetric, then it'll center in the middle and click check. And we have a pair of legs. And then the final thing I'll talk about is the final creative part, which is decorating the face, which is usually the fun part for all the students. You can like take a front plane. Again, you're getting very creative with this part. So I usually just like live in the spline part of, I'll just like draw some crazy hair that like kind of looks like mine.
Oh, and then you can rotate it.
Yeah. So lots of different options. Does that look like me yet? A little bit.
Mirror image.
And click check and then extrude that one as well. for this one, I'll also want to make sure I spin it around to make sure it's not offsetting weirdly. I don't want my hair all the way in front of my head, so I will do another symmetric and then it'll sit more on top. Ah, there I am. So I'll give you guys a few more minutes to play with it and ask any questions because we're gonna move into the final part. Our time is wrapping up really quickly. I'll make my final arm as I wait for questions. But feel free to shout them out if you have any questions. Woohoo!
Can students change the color of these shapes?
That's a really good question. Yes, you can click on these 3 circles on the right side, and that's an appearance panel. So you see how the legs I made are gray and the top part is blue? You can adjust those. I haven't played around with it too much, but then you can play with the colors here.
Awesome, thanks.
Yeah.
Connie, I have a question actually.
Yes.
If you wanted to align the 2 arms,
Mm-hmm.
how would you do that?
Yeah. One way you can do that is you would just make sure. So if you saw for the other arm, like for, I think it was sketch 3, that was my other arm. We can scroll over to that. It's all black because I made sure that it was centered in both the middle and top. So the way to make things match is to just have them have matching dimensions. So I made sure it's 1.5 by 0.5. And then the part that I could move around was where it was positioned, but then I made sure it was in the center of the width and the length. So I was less careful on the other side, but so you can see it's like a little more raised. But if I go back into that sketch, you can see that it's still blue. But if I did the same like line through it, situation, drag the dot, it would be able to center in the same place.
Thanks.
Yeah, thanks for asking. Alrighty. If we don't have any final questions, we're going to move into the wrap up.
I have a question
Go for it.
about maybe not specifically about this, but if I had created some stuff in SolidWorks, can it be imported into Onshape or vice versa?
Yeah, you can import. I'm blanking on which file name it exactly is, but there are different, like, I think it's like STL files or some, like a certain file type that is compatible across all. And that's how they store the data.
Cool, thanks.
Yep, so it is possible. You just need to find the right file type. Great, so the final piece we want you to leave with is to be able to share Onshape with your students. You can contact us anytime. You can reach all of us at hello@projectinvent.org. You can find more resources to learn design thinking, engineering, entrepreneurship on our website and through various lunch and learns that we're hosting throughout this season. And a large reason we're hosting these as well is to make sure you guys are all aware of additional opportunities to get involved in. A big one of those is Pathfinders and our fellowship. Both are largely free for public school teachers. So if you're in a public school setting and whether you teach elementary or middle or high school, these are all really good opportunities to just deepen your knowledge and how do you bring not only things like computer aided design into your classroom, but also how do you help students choose a problem that they really care about and learn all of the tools in design thinking, engineering, and entrepreneurship to create an invention that can really make a difference. So that's all we have for you. Feel free to stick around if you have any questions, and otherwise enjoy the rest of your afternoon.